All right. Hello, everyone. Good afternoon, and thank you so much for joining us for this today's event. I'm really hoping that you guys were able to really get some good takeaway about the AWS as a platform, as well as our like APN advanced tier partner Status 10, and to know about their superpowers and where they can really help you get their streamline your journey to the AWS cloud. With that, my name is Nirav Shah, and I'm a senior solutions architect at AWS. Been with AWS for close to 2 years, and as a primary like part of this team at AWS, I try to work with closely with many of our key customers as well as the APN partners to help them expedite their journey to AWS and provide the technical guidance about any of their like technical workload or business needs that they have. So today's session, hopefully this is the last session, so I'll try not to make you guys bored. I'll try to quickly cover about different databases and the options that we have on AWS to provide. A brief agenda. We'll be talking about like database services that we have and some of the common traditional challenges that we have seen across like traditional database systems and the solutions and the applications that have been built around, and how we have evolved to solve many of these different problems with different offerings such as RDS, Redshift, DynamoDB, and this varies from a SQL database to all the way the different kind of workload which requires a NoSQL databases or in-memory caching for low latency requirement, or even like building a kind of time stream applications which requires doing a lot of heavy lifting if customers would have to do on their own. So at AWS, we have more than 15 purpose-built database services. And we believe to provide all the flexibilities to our customers because we believe like there should not be one tool to rule the world, and that should not be one problem to all the, one solutions to all the problems. So we have different database services that we provide our customers to best fit their need based on their workload. We have broad range of services. Those are completely meant and build a purpose built for every major use cases. And these services are fully managed that you can see on my screen out of all those 15 different services. And that allows you to build the application that can easily scale to meet your customer needs. And all of these services are battle tested, and they provide deep functionality. So you can get many of your key architecture requirements such as like high availability, performance, reliability, security. Those generally are really required to support your production workload. So just a background about like how traditionally we have been building the applications with the three tiers. So at the bottom you can see we have RDBMS systems, and then we have app tier, which basically does a lot of read and write operations to our RDBMS systems. And on top of that we have the client tier, which is mainly meant for the presentation tier. So this approach seems to have worked fine, but if you can see the design for like the relational databases in traditionally are meant to run on a single server to maintain the integrity of the table mappings, or even in order to avoid any kind of problems for the distributed computing that their applications reads. So challenges that can arise is like a system needs a kind need to scale to meet the customer demand, or even customer in those kind of situations end up buying bigger or more complex and sort of expensive proprietary hardware to work with to add more processing powers and memory and storage. So that is one of the problem. But apart from that, also like in case you have to deal with like future upgrades, those are also challenging. And then organization in those situations must have to go through a lengthy process to acquire this kind of resources, and sometimes they even have to take their system offline to actually make those changes available to their end customers. So What I'm trying to tell here is one size fits all the approach of using the traditional relational database systems seems to only store for your application in previous days, and that approach does not work any longer. And if you can see, like, all of your applications are going to have a different requirements. Some of them are used for the online transaction management, some of them are used for the analytic purpose. And in traditionally, we used to build applications which end up using all the heavy lifting, or every like key requirements have been handled by single database or RDBMS systems. So this approach seems to work fine, as I mentioned, but as of today's trend where the applications are going with a very low latency, people are looking to build application with the micro level millisecond requirements, not even like the seconds kind of requirement that we used to see in the earlier days. And then if you expand a little bit more about the data tier architecture, you could see at the bottom, we have many different use cases. Some of the applications on a high level can fall under the caching, where they need a high level of caching in memory requirement to like cache many of their data, and to avoid a lot of network traffic, and also provide a very low latency yeah, kind of user experience for many of their applications. But it can varies from like a data warehousing requirement for analytics use cases, or even like search kind of requirements, or even building a kind of key value storage where they only want to store kind of key and value objects with the NoSQL databases. So the application data tier, if you see here, has a broader scope than just having like one single database or one database that can serve and solve all the problems. And that's where like we have different services to solve, which can very well align with different criteria of the data tier to help customer build their applications, which is meant for the choosing the right tool to do the right job in this kind of situations. So if you can see, we have different data tier and the services. So for example, like for a high traffic web application, such as e-commerce systems, or even like building a gaming applications, customer can generally use an in-memory database such as Amazon DynamoDB, which I'm going to highlight where these services sits in terms of this criteria. So if you can see, like we have caching, NoSQL requirements, or search or blob level storage or time stream database, and how we correlate those with our AWS services that can help customers solve those problems are here. So before I go into the next slide, I want to highlight some of the use cases. So as I said, like for the e-commerce or gaming applications, customer need a high level caching, or even like they sometimes needs a document database. Over there we have Amazon DynamoDB, or even like if they want to build a kind of content management or a catalog or user profile, which is compatible with their on-premise MongoDB capabilities. Now, given the trend, customers are also building a fraud detections or social networking or recommendations engine. So we do even have offering called Amazon Neptune that can even help customer build these relational and graph database systems. And then use cases where you required a heavy level of caching or session management, or I would say you are building a game application, say you want to maintain a leaderboards. So those kind of use case basically falls into the in-memory database requirements, where our Elastic Cache can help customers. We provide two different implementations. We will briefly touch upon in our subsequent uh, slides and presentations. And similar to that, we have Redshift for managing a kind big like a data warehouse requirements with a large petabyte of scale that customer can do. So we'll quickly touch upon some of the services that I'm highlighting. So how those services maps in each of these high level data tier workloads, like from Amazon Elastic Cache from caching requirements to Amazon Redshift for the analytics and data warehouse requirements, as well as for using the RDS, where you can have multiple options to run your existing commercial grade database system, but with fully managed service where you can run complex joins, but still you don't have to worry about managing the infrastructure, patching, or any kind of underlying heavy, undifferentiated heavy lifting that you would have to do. With that, we are going to quickly talk about what is RDS. So RDS is a fully managed relational database service, and we provide multiple choices for our customers to let them run their workload. We have multiple options to choose from the commercial grade databases that they can run. They are running on their on-prem, or they can even run on RDS, Amazon RDS using MySQL servers or Oracle. And then we have different offerings to support the MySQL, PostgreSQL, MariaDB, and we have our own like Amazon Aurora as well. So customers who are running commercial databases, as I mentioned, like Oracle, SQL servers, they often choose to migrate to Amazon RDS, which is fully managed, as I mentioned, and they have different options to go and scale it out and run with their existing licensing models that we have, or even we provide RDS with an inbuilt licensing model, so customer does not have to worry about some of the licensing complications that they have to deal. But the key thing that they would get away is it improves the database scale and the performance, and also automates many of the time consuming administrative tasks such as hardware provisioning, database setup. They probably have to deal with the patching, or even the key part where most of the DBS spend time is also about doing the backups and other recovery processes. So it's a highly available and it gives a lot of key advantages for the customers to help them run their existing or any relational database workload on Amazon RDS. So just like if you would have to do all of these things on your on-premise data center. So let's say if you have different use case, different applications, and then if you're going to run all of that, and this is something like most of the time customers have been doing, they have to deal with a lot of under the need kind of infrastructures and requirements. For example, like from power, from the colo locations or their own data centers to the server maintenance, and then all the other system administration, such as managing the patches, license and software compliances, to make sure any security patches or anything, you have to constantly keep upgrading your on-premise center of the infrastructure that you are running. And then also like you have to take care of like the database backup, making sure your applications are highly available, and many other like key challenges that customer generally would see. So with RDS, like we have two options. Customers can easily choose to run their on-prem data, like databases, like to EC2 hosted, where they can bring their database and host on self and manage EC2 instances. And we take care of many of these key aspects, like including the power or server maintenance, OS installations is already been taken care by AWS. So customer does not have to worry about all the aspect, and they can easily run their additional database workload on Amazon EC2. And then when you go with the RDS, we take it even further. So that means when customers goes from instead of running on the EC2, if they even choose to run on the RDS, we take care of many of the even additional burden that they would have to take on. So for example, scaling, we make sure the like the database instances are highly available. We take care of any OS or any installation patches that we have to do for our customers. And even like we take care of the automatic backups as well for the customers like database workload that they run on the RDS. So as you can see, this helps customer to free up many of the resources to basically work on the key differentiating like innovative ideas that they might be working to help their end customers, and just focus on the application modernizations or other areas, and don't have to worry about any of the underlying heavy lifting. So some of the key features I think I have briefly touched upon, but with RDS, customers can easily go build a kind of highly scalable and reliable architecture. They can have a multi AZ deployment where they can have a masters running in one node, one availability zone, and they can have a slave which can be spun up in different availability zone to make sure they are highly resilient and available. And the replications and between these two availability availability zones happen synchronously with the highly connected fiber optic cables, and they provide more than 100 gigs of connectivity. So this makes our customers easily spun up their build highly available architecture. And then when there is a need to scale the capacity, customers would have an ability to go into the console, and with the one click push button, they would be able to scale up their storage, or even they want to go with the higher memory optimized instances or CPUs. Those flexibilities are easily available to our customers. So it's really improves their availability. It really helps them increase their throughputs. At the same time, having the our own backbone architecture helps customer reduce that latency, low latency between those workloads. And then customers, in addition to have the master slave, they also have ability to go with one masters and have multiple replicas, where they can have a read and write can be separated from the workload, and they can just use the read replicas for any of the read intensive requirement that they have. Taking it further, so Amazon Aurora, I have briefly touched upon, but Amazon Aurora is a MySQL and PostgreSQL compatible relational database, which is built for the cloud. That combines the performance and the high availability of high-end commercial databases that we have been using traditionally. But the key part that it brings is the simplicity and the cost effectiveness of many of the open source databases. So for example, Aurora has 5 times better the performance of the standard MySQL that you would be running on your on-premise. At the same time, it also provides a 3 times better performance than the standard PostgreSQL. So it gives the customer the better security. It gives customer the better availability. It also gives customer the reliability of the commercial grade database, but everything you get at the 1/10 of the cost. So if you compare the cost between your running all these databases on your own versus with Aurora, the you get all these things with the 1/10 of the cost. So those are the really key advantage that Amazon Aurora provides, and it's one of the very popular services across all the database service that we have. A very brief architecture about the the Aurora. So all of this Aurora, when you use, have a master, and then it already provides capability for you to create the multiple replicas. But the key part is your storage and compute is not tied together. They all work with the shared storage volume. And as you can see, every data that you write in any of the availability zone has 3 copies of those data has been stored into the same availability zone. But not only that, it makes it highly durable and available across 2 more availability zones. So that means your storage that you have stored in one availability zone is highly durable within the availability zone, plus across total three, that means 2 more availability zones. And this gives customers a very highly durable storage and a platform where they can easily build a highly resilient applications across multiple availability zones. Some of the benchmark, I'm not going to go in too much details, but as I mentioned, like it gives 5 times better performance on the MySQL, as well as, so this one is mainly focused on the MySQL. So as you can see, the trends about the reads and the writes performance and the throughputs, it definitely gives much better like performance compared to when you have to run this commercial grade database on your own. And similar benchmarking for the PostgreSQL version as well. It provides a 3 times better performance than you would probably have to run on your own. And then just a quick everything that we get from the RDS. As you can see on the left, a database on premise, that is something completely managed by you. On a database on EC2 is something that we take care of managing. If you decide to run your workload on EC2 self-managed environment, or if you decide to run on RDS, you can see you only have to focus on your application optimization, and rest everything has been taken care by AWS and Amazon RDS. A quick overview of like how you can scale the storage. I think we have briefly touched upon that, but in nutshell, it can take care of doing the auto increment in 10 gigs of the unit. So you don't have to worry about like going and adding an additional storage when your workload increase and your data volume increase. This has been already taken care by you for this kind of situations, and that increment happens in 10 gigs in size. Another key feature about the multi-master is, for example, is a new feature of Amazon. I mean, it's a new feature of Aurora MySQL compatible edition, and that adds the ability to scale out your write performance across the multiple availability zones, and that allows applications to direct read and write workload to multiple instances in a database cluster, and that also gives the same high availability that you generally get. So in a multi-master cluster, all your database instance can perform the write operation. And that's a key differentiator between having the read and write or having one masters and having the multiple reads. In this design, you would get an ability that all of your database instances can have the write operations being performed simultaneously at the same time. And then the global database is, again, as I mentioned, you can have a master database being spun up across in one availability zone, and you can even promote any of your read replicas in case of the disaster recovery to, let's say, if you have a multi-region architecture, you can have a masters running in one region and then have read replicas across the multiple regions. In case of disaster recovery or any events happens, you can easily promote any of your read replicas to take on as the master, and that way your applications still is highly available and durable across the regions. This is another service which is an on-demand and auto-scaling configurations for Aurora. It's a serverless offering that we have where the database will automatically start up, shut down, and even scale the capacity up or down based on your application needs. So you don't have to worry about provisioning and knowing like how much basically the resource size or storage you would be needing. So this is a completely serverless offering. So you only have to worry about. It's actually very cost effective options for infrequent or like any intermediate or any unpredictable workload that customer might be expecting to run. So that's all about the RDS and Aurora. I'm quickly shifting gears towards the Amazon Redshift. And Redshift is a fast, fully managed cloud data warehouse that makes it simple and cost effective to analyze all of your data using a standard SQL. And it can easily integrate with any of your existing BI tools that customers are using. As I mentioned, it's fast. It is designed based on columnar storage to help customer build the very low latency and high throughput read and write operations. At the same time, it's very inexpensive compared to other BI tools that customers might be using on their on-premise. And it can easily scale up and scale down, and it can support some massively parallel architecture which can handle the petabyte scale of data for any of the BI needs that customer would be having. And it's highly secured and integrated with many of our key security services. Just like you can, when you work with the Redshift, you can spin up the cluster, and the cluster is going to have minimum of one node, which is going to be your compute node, or it can even have more than one node. So in case when you have more than one compute nodes, those compute nodes are going to have a leader node given to them at the time when the cluster gets spun up. And the leader node, everything that you do with the Redshift cluster, your applications or your JDBI or BI tools or any client application will be always talking with the leader node, and the leader node behind the scene takes care of distributing all the compute queries or finding the right execution path for those queries. And all this heavy lifting and coordination is done underneath with all the compute nodes. So when you deal with Redshift, you never deal with any of the compute node. Instead, you always deal with your leader node. So this is like a very underneath architecture, and this gives a very highly parallel compute optimized environment to run massively parallel workload queries. We have briefly touched upon some of the requirement and the designs, but another key feature is a Redshift Spectrum, and it's a feature of Amazon Redshift, and that enables you to run the queries again exabyte, not even the petabyte, but exabytes of unstructured data that you have stored in your Amazon S3, which is our object level storage service. And the key part is you can do it with no loading or ETL required. So this gives a very convenient way for our customers to not only query the data in their data warehouse, but they can also query the data which is stored into the S3, which could be unstructured data. So Redshift Spectrum is definitely one of the key service that most of our customers are also leveraging along with the Redshift. Quickly moving on to our next set of database service, which is Amazon DynamoDB, and is a key value and a document database that delivers a single digit millisecond performance at any scale that you can imagine. It's a fully managed multi-region, multi-master, and also a durable database with built-in security. It also has a built-in backup and also takes care of doing the restore. And it's also provides an in-memory caching for many of the internet scale applications that customers are having more and more use case as in today's market. So I think I already touched upon some of these features. Fully managed, it's a very cost effective because it's a serverless offering. So customers have different options to define their throughputs, read and write capacities that they can define. They can go very granular in terms of the securities on the table level and the row levels, that how granular they want to go. And it is also very easily integrated with many of our different AWS services. I think Amazon Redshift that I already discussed earlier, it is very easily integrated with that, but it's also integrated with many other services that we can see. So just like key advantage and benefits is highly available, it's durable, and it's designed to support almost 99.99% of availability for any of your data that you store. And the data that you store in DynamoDB, we take care of doing the replications across multiple different servers and clusters in the behind the scenes. So you don't have to worry about that. And the storage are highly backed by high performance SSDs for all of the read and write operations that you have to do with the low latency requirements. And the data that you store is by default always get replicated across 3 availability zones that we have seen, similar to any other service that Aurora or other service that we already provide. So it gives you an ability to do a backup and restore. You can even go and do a on-demand backups for your data. And we even take care of doing the automated backups, but you also have an ability to go and do a point in time recovery and restore for any of your data and tables that is stored. And then the global table. So let's say, for example, this is a really nice feature which provides a fully managed solutions for deploying a multi-region, not only a single region, but let's say if you have customers who are sitting in North America or Europe or Asia's in different globes, this gives an ability for you to deploying a multi-region, multi-master database, and that all without having to build and maintain your own replication solutions, because we take care of doing the replications not only within the AZ, but across the regions where you have spun off your databases. And this gives a lot of flexibility for customers to do. For example, like maybe you are having, you can update their profile informations using the applications, or any of the key requirements where you want to have your data being applicable and with low latency across the global. This is already taken care by global table approach within DynamoDB. Just quick cap. I don't think so I have to go into detail, but customers always have these questions how to choose. So the DynamoDB would be when you really want a very simplest possible DB management, or you want your apps to, with the data integrities. It does provide those flexibilities to choose. But RDS is traditionally, as we have seen, meant for like when you have database or applications which is highly dependent on relations of your data, which requires a joins, or you need to make sure the ACID like the properties or transactions, and want to manage any of your existing database, this commercial database system you are using, or you want to have a team who really is geared more and more towards the SQL's requirements and SQL skills. With that, I'll move on to our next engine, which is Amazon Elastic Cache. And Amazon Elastic Cache is a web service that makes it easy to deploy, operate, and scale any in-memory data store and cache in the cloud. So this service improves the performance of any of your like high requirement, high throughput, or very spiky or busy web applications, or any of your other business needs. And that allows you to retrieve the information from the fast, manage, and in-memory data store instead of relying entirely on a slower disk traditional databases that we have seen. It's extremely fast, provide the extremely fast performance, which is sub millisecond response time at any scale. And it's a fully managed. That means you as a customer would not have to worry about spinning off many of the different under the hood of infrastructures or clusterings and nodes and everything. We provide two different implementations of Redis as well as the Memcache D. Those are the two different implementations and supports that we provide with Elastic Cache, and it can easily scale up the clusters and the nodes that you create. So you don't have to worry about all the complex things that you have to work with any of. If you have ever used Redis or Memcached, you probably know like the complexities brings when managing the clusters. So some of the use cases and the features, like if you are building a gaming leaderboard applications or financial trading applications, or even like media streamings, or if you want to have an application which can store the session state to make it stateless between like your representation or application layer and the database layer. Or even like having a ride sharing applications. So those are all the different use cases where customers needs to cache some of their data based on either on the database level using the Memcached, or they can even have an application level using the Redis kind of use case. And it provides all the good features that we have talked about, make it global, easily provide the millisecond performance, and handles millions of requests per second. I think I'm not going to go into much detail for this one, but yeah, we provide the Elastic Cache, Redis implementations, and Memcached both, which are open source. So you even are using any of this on-premise, it's very easy and seamless for you to migrate to Elastic Cache, and you don't have to worry about all the complexities. You can still bring all of your existing clusters or the setup that you have done and have it deployed into the Elastic Cache. Similar features that we have just discussed earlier. With that, I'm going to move on to our next offering, which is Neptune. So Amazon Neptune is a fast, reliable, fully managed graph database service that makes it easy to build and run applications that work with highly connected databases. So the core of the Amazon Neptune is a purpose-built, high-performance graph database engine, and which is optimized for storing billions of relations and help you querying the graph with the millisecond latency. So this is really good for like if you are building a social media applications, or you need to find the relations, or even you are building a recommendation engines, or even if you are building an application who base, for example, you are having a commercial e-commerce applications where you want to browse all the related items that you want to recommend to the customer based on their browsing histories. So this gives a really streamlined ways, fully managed service to help you build all these relational graph database requirements. It's open. That means we are using it supports the Apache Tinkerpop as well as the W3C RDF graph model that even if you are using as of today on premise, it's a fully scalable and fast, and it can help you store billions of relations. When we talk about the graph database, it's all about the relations that you store, and then you can query those with millisecond latency. Highly reliable and easy to build and use with existing tools if you are using and familiar with these tools on your on-premise environment. Some of the use case I think we have already discussed. If you want to build a kind of relations or social networking applications, you want to build a recommendations or fraud detections or any other graph related use cases can easily be handled at scale with Neptune. We have already touched upon this one. And then I'm going to move on to our next database offering, which is our time stream. It's a fast, scalable, and fully managed time series database for many of your IoT, Internet of Things kind of devices, where basically all the data gets streamed to your service, but you still want to manage the time series relations where the data has arrived, and all of your business operations and requires those sessions to be maintained. This makes it easy to store, analyze trillions of events per day. And the same goes back with the 1/10 of the cost with any of your, if you have to build something like this on a traditional database, the cost will be significant compared. And not only the cost, I would say even the complexity will be much, much higher than handling this kind of use case with the relational database. So some of the comparisons around like what is required, because in time series data processing is really complicated when you have to store those data and manage the essence in the relational database, versus like they ends up becoming sometime hard to scale. They have the limited like capabilities in terms of managing your data life cycles and managements, and also it's very sometimes becomes managing the schemas for moving the time series databases also requires a lot of skills and handling and over like work that you have to do. So with Amazon Times Stream, it provides faster performance at 1/10 of the cost and can handle trillions of events a daily from multiple sources that you can imagine. And it's a fully serverless. That means no server to manage, at no time consuming task you have to perform for managing, configuring, or even like patching or upgrading any of your underlying softwares and setup. Um, and then our next database is Amazon QLDB, which is a quantum ledger database system. It's a purpose-built ledger database that provides complete and cryptographically verifiable history of all the changes made to your application data. So many of the systems requires the data that is been stored to be immutable and transparent, and has to be very available and scaly. It's a fully managed ledger databases. So we take care of managing the underlying infrastructures and everything for you, and you can build your entire system using the QLDB. So this QLDB gives you the immutability. All the data changes written to and append only journal, if you are aware of this concept, and that cannot be changed or even deleted once you write it. And the data in QLDB is verifiable. That means you can create a hash change on the journal, and you can always verify the integrity of the data. And it also maintain the data history, which is transparent. You can query, you can analyze the data, and it's always going to be trustable and accurable. And it's very fast, handle the scale with many millions of requests per seconds, and it's a very scalable database. So one of the key advantage is having it to be serverless as well. So highly, on a very high level, how it works, if you can see in the center, we have a quantum ledger database, and there are two aspects to that. One is the current state and the index history, where basically it maintains all the current state of your data that you are writing, as well as the history. But the most important part at the bottom, if you can see, is a general, which is like the append only like immutable journal, where it stores all the sequence, anything is cryptographically made entries, and any, for example, like if you have a credit cards or if you have a debit related transactions and all, you want a storage which is immutable, so nobody can basically delete it or nobody can verify it. So those are the two key components on a high level for QLDB and how it works. Common use cases, customers can use it for the e-commerce to track all the activities from the beginning to end, for from where it is arrived, or even like transport or logistic, or even like government, like a DMV use cases where they want to make sure the vehicle entries or titles, histories, or anything, they want to make it immutable record that they could track, or even banking and financials where you see more and more use cases, customers are using QLDB. I think I already touched upon this features, and now we will be moving on to the last data solution, is Amazon Document DB. It's a fully managed Mongo compatible, fast, scalable, highly available, and solution that support the MongoDB workload. And as a document database, Amazon Document DB makes it easy for you to store or even like query and index any of your JSON-based document that you would store into the MongoDB. So document database type of a NoSQL database. So Amazon Document DB makes it easy for many of like aggregations or any data performance requirement that you have for the JSON-based document database. So I think most of you guys should be aware with the JSON, but just in the essence of time, I'm not going to say like why customers basically choose document database. There are many different use cases why people are using the document database to solve many of their business problems. And some use cases, customers use it for content management or mobile application development, or even managing the user profiles or catalog, some of the examples. And like if you have to do and solve the same problem with the relational database, so if you can see in the design, if you have a table and then tomorrow, let's say a customer has designed a table with username, first name, last name, and if they have a need to add that table with additional features, which can even store their score or even like the ranking, in a relational database, you end up having a two different tables and do a joins between them. But with having a NoSQL document DB, you don't have to, it's a schema list, so you don't have to worry about defining the schema upfront, but those documents can be added with additional features into the existing document that you have. And it can contain both the one with, for example, in this case, with the tank flight information and the one without it. So you don't have to go and upfront define the schemas and do a modifications and EDLs and everything. And then if you have ever used MongoDB on on-premise, it requires a lot of operational overhead in managing the clusters and spanning it and making it available and highly durable. But when it comes to Amazon, so the previous approach in traditional way is going to increase a lot of like cost of ownership that you have to do. You only need certain people with the skill sets to manage, and then time to scale up and down becomes even difficult to manage the ongoing customer workload. When it comes to Amazon Document DB, we take care of managing many of the key aspects like the high performance, throughput, highly available. We manage the underlying infrastructures. It's highly integrated with many of our security services. And as you can see here, we simplify the entire underneath architectures and the management aspect of this. It's a fast, provide automatic storage, scaling, analytics. You can run different use cases to visualize your data, and it can support millions of requests per second with millisecond latency, and provide the higher throughput than traditionally you can get with your any on-premise MongoDB.